This video is one more very fancy sounding theorem that is actually quite simple. It's called the complex conjugates theorem. Fancy words, but it's a simple idea. The complex conjugates theorem is that if a plus bi is a zero of a polynomial, meaning if you have an imaginary root of any polynomial, its conjugate, a minus bi, is also a root. That's it. That's the theorem. In other words, imaginary roots always come in pairs. So write a polynomial function of least degree whose roots include 3 and 2 minus I. The of least degree is just the question's way of saying don't get fancy, just like keep it as simple as you can. Of least degree means don't do anything extra, just the bare minimum. So our function is going to have roots at 3, which means there's a factor of x minus 3, and a root at 2 minus I, which means there's a factor of x minus 2 minus I. But remember that 2 minus I I'm subtracting, it's really 2 minus I is a root like that. So I should really call that 2 plus I. But that doesn't even really matter all that much because of the complex conjugates theorem. If 2 minus I is a root, so is 2 plus I, which means x minus 2 plus I, which is going to distribute to 2 minus I. It doesn't really matter which one I used a plus, which one I used a minus. There's going to be one of each. So that is my polynomial function. I don't want to have an I in my answer, so I do want to FOIL this one out. My recommendation to you for foiling is, even though the I's are annoying looking and a little bit frightening because we're not so used to them, deal with them first because they'll cancel each other out. So I'm going to hold on to this x minus 3 for just a minute, and I'm going to FOIL out the x minus 2 plus I times x minus 2 minus I. There's going to be 9 products here. It's going to look a little bit annoying. You can use the column trick I showed you last class to keep it organized. X times x, x times negative 2, x times negative I. Negative 2 times x, negative 2 times negative 2, negative 2 times negative I. And the last 3 are I times x, I times negative 2, and I times negative I. But so much of this cancels out. We knew this was going to happen because we were multiplying conjugates together, so a lot of things are going to cancel out in the middle. The negative ix and positive ix cancel out. The 2i and the negative 2i cancel out. And the negative I squared is going to become negative negative 1, or just positive 1. So when we're done cleaning this up, we've got x squared, the negative 2x minus 2x combine, and 4 plus 1 is 5. So like I said, deal with the i's first because they will cancel out. And then to do my last foiling, x times x squared, x times negative 4x, x times 5. And now I'm going to make columns for like terms here. Negative 3 times x squared, negative 3 times 4x, and negative 3 times 5. So x cubed minus 7x squared plus 17x minus 15, that is your function. Some of you might be saying, hey, I thought we were supposed to deal with the lead coefficient and find out what a is. The reason I don't have to worry about that right now is because the directions said write a polynomial function, not the polynomial function, like not one specific polynomial function with a specific y-intercept. This is any polynomial function. I certainly could have multiplied this whole thing by 2 and it would still be correct, but why would you make your life harder?